Energy is at the root of the economical and social development. You cannot develop economically and socially if you don't have enough energy. So I think this applies all around the world, and cooperation between countries is fundamental. The decision on whether to do nuclear is up to the governments. But for the governments which have decided to do it, it is very important the international cooperation to do it the best possible way. So what we try to do is to give them very good indications, recommendations, guides on how to use nuclear power from the safety point of view, from an environmentally friendly point of view, and from an economical point of view. What we try to do is just to have the best specialists from the OECD countries discussing together from different countries what are the best practices that you can do to do the things well.
So the U.S. started with nuclear energy in the 70s, and then it just sort of stalled. What are your perspectives on what happened there in the U.S.?
Well, I think that in the US several things happen at the same time. One thing is that, of course, Three Mile Island had a tremendous impact in the industry because they realized that, safety was an important issue and that, you could have an important accident. Three Mile Island didn't have any impact outside of the station, so there was not any danger for the population, but from the economical point of view, it was a disaster. So this is a warning to the industry. On the other hand, we were living at that time in years in which the oil was very, very cheap. And really, the incentive for investing in nuclear power was not economical. So I think from taking those two factors into account, it is clear that the utilities in the US thought that there could be other alternatives to the produce of electricity rather than nuclear. But still, United States continue operating the reactors they had built, and in fact is the biggest fleet in the world. They have 104 reactors in operation, and that's a very important part of the world energy. So I say that there was not new investment, but the industry tried to get a lot of experience in operating the reactors. And they were very successful because the performance of those reactors has been improving significantly since then. The capacity factors, the number of hours you operate during the year, were growing very significantly. 30 years ago, they were about 65%. Now they are about 90%.
90%?
90%.
US, and they use that all for base load?
For base load, and it's very reliable. And I think from the economical point of view, once you have paid amortization of the initial investment, really they are very cheap. The percentage of electricity from nuclear in France is around 78%. It's the highest for a big country in the world, and represents, and this is a very important thing, as much energy as all the oil in Kuwait.
What are the key things that have let France be successful in nuclear energy?
Well, I think that France has been a country in which nuclear has not been in the middle of the debate between the left and the right. Practically all of them in the parliaments, in the political parties, were considering that nuclear was very important for la grande France, le grandeur. And de Gaulle was able to articulate that very well, and this is very deep in the political establishments of France.
So great education.
Great education and an approach to consider that nuclear is science and technology, is in our hands. We know that. Why we are going to renounce to that? Why we are going to import oil or gas from other countries when we have scientists and technologies which can provide us as much energy as Kuwait gives to the world? And this is very deep in the political establishment. Basically, the French society has always considered that they were benefiting a lot from nuclear power. France also has a big tradition of public companies which are very efficient. So really, they were able to articulate a system which has been efficient. They decided to standardize nuclear power plants with the same technology, and this has proven to be extremely important to have a very efficient system. And I think the success in France is that through standardization, they were coming with a model that represents a very, very rational approach to build the nuclear power plants. Because nuclear power plants are very sensitive to the change of design, different teams making the construction and all that. The success of France has been to standardize all that. So I think that in the decades to come, the main connotation about France is going to be the export industry, how they are going to help other countries with nuclear. One important element of nuclear is that nuclear is science and technology. The role of the uranium in the production of kilowatt hours from nuclear is very, very small. In fact, in the cost of a kilowatt hour is only 5%. The other 95% is science and technology. And this is very important because it helps in developing a high-level society. And also, it's very important for the OECD countries because these countries have that technology. So with a little bit of uranium, you can produce a lot of energy. So I think this is a very important consideration of nuclear.
Yes.
Second, nuclear contributes significantly to the security of supply because almost 40% of all the resources in the world are in OECD countries. The main resources in the world are in two OECD countries, Canada and Australia. And Kazakhstan is the third one, but then United States comes. So this means that if you put these three countries together, Canada, Australia, and United States, which are very reliable from the market economy, they are members of the OECD, gives a lot of confidence. So this means that from the security supply point of view, nuclear, uranium for nuclear power is very different from oil or gas and contributes in a significant manner to the security. And the third element, which has become very, very important in the last year, is climate change. Climate change is a big concern, and nuclear power does not produce CO2. Well, there are some people who says, yes, this is true in operation, but what about mining, enrichment, conversion, and all that? Well, we have made an analysis of the whole fuel cycle of nuclear power from cradle to grave. And the emissions of CO2 are nothing in comparison with coal or natural gas. In fact, are of the same order of magnitude than wind power.
Is it affordable? What's the cost per kilowatt hour?
I think at this moment you could think about 60, 65, 70 euros per gigawatt hour.
Okay, per gigawatt hour.
Per gigawatt hour.
Okay, so maybe 5 or 6 euro cents per
kilowatt hour.
That's very affordable.
It's very affordable, but nuclear is intensive in capital. So you have to put most of the money at the very beginning.
Okay.
About 60 to 65% of the cost of a kilowatt hour from nuclear is the initial investment in the facility. And that has to be put at the beginning. When we make an analysis to compare the cost of the kilowatt hour from different sources, we are talking about periods of 40 years. In 40 years, nuclear competes very well. But the amortization takes 25, 30 years, while the amortization of natural gas could be done in 7 years.
Right.
So nuclear is very attractive economically when you have a good financial situation and you are going to be in the markets for 40 or 50 years. Then it's very cheap. But for small companies and for countries who have not access to a good financial results, sources, for countries we don't have infrastructure, they don't have qualified people and all that, nuclear is difficult.
So why is it so expensive to build a nuclear power plant?
Well, because the equipment you need, both for the process itself and from the safety point of view, really are very complex. And that's very important. To give you an example, an important part of the cost of a nuclear power plant is the containment building. You cannot live without the containment building. Also, the equipment in itself is high quality. The materials are selected in a way which is very, very strict. Of course, when you standardize, this is much better from the economical point of view. But still, nuclear has high capital investment at the beginning, and this is a fact. In France, they have not too much of a problem in finding sites for nuclear installations because the society accepts well nuclear, and also because it is clear that nuclear installations bring you a lot of qualified people to the region, many compensations in the area, creates employment.
Good jobs.
So yes, very good jobs. And this means that in many occasions there have been many towns which were really asking for having additional nuclear installations. But one of the characteristics of the nuclear program in France is that they do reprocessing in LAC. So this means that they don't dispose the spent fuel directly after utilization in the nuclear power plants. So this gives much more time and also reduce the waste to only high-level vitrified waste. The volume of high-level waste from nuclear high-level waste is very, very small, and we know how to do that.
What does very, very small mean? I heard in the U.S. if you were to take all the waste from all the nuclear energy all together, it would cover one U.S. football field, 15 feet
well,
deep.
in France, that they reprocess, they say that the whole program of France, 58 units for operating 40 years, is equivalent in volume to 2 Olympic pools.
2 Olympic pools.
Yeah.
That's the total volume for 40
The total
years.
volume for 40 years. And it has the benefit that you can use the material for providing much more energy in the future with MOX fuels. So from that point of view, it's a rational way of utilizing nuclear power.
Any insights into the storage facility? Is that available yet? Are you looking geologic storage?
Well, when you talk about high-level vitrified waste, you are talking about deep geological repositories if you want to store them, to dispose there forever. Mm-hmm. And this is what they are developing now. Yeah. Of course, these canisters can be stored in many places. Waste is something which is passive. It's not like a nuclear power plant which is active. There is an active process. No, it's very passive. So this means that you have a lot of time for reaction if something is wrong, and it is very difficult to have a criticity in the waste. So the important thing is to isolate that from the people. And we have been for many years working in the analysis of the geological repositories, trying to develop the methodology for having a very good safety assessment. Sure. And the conclusion of our expert is very clear. If you put the high-level waste at about 700 meters deep in a geological area which has been stable for millions of years and where there is not access to water, and you prepare some engineering barriers, then really there is no risk for the population. Yeah. The 16 reactors, generation 2, and now the modernization of that, which is generation 3, are working very well. But it will be very interesting to have nuclear power which is more economical, that you need less of initial capital investment, that you can also reinforce the safety, that you can reduce the waste which produce, and which are even more resistant to proliferation. So this is very important, and an international project has been developed to try to develop technologies for the future which are very advanced and which could respond to better meeting these objectives. So an important international team, starting by United States, were analyzing all the possibilities of nuclear technology for the future, and 6 new advanced technologies were selected. So now 10 countries are collaborating in developing the research which is needed to develop those technologies in a way that could be put in the markets. That's the intention. It's not just research for the sake of research. Sure. The idea would be to have, in about 30 years from now, in the marketplace, these kind of reactors. Most of these new technologies are what we call fast breeder reactors, which with a closed cycle. A closed cycle means that you reprocess the spent fuel, and with that you have more fuel, because a very small percentage of the energy is extracted from the uranium with the light water reactor. If you reprocess the spent fuel, you can have access to much more energy. We analyze the uranium as a resource. 100 years is at hand, and if there is more exploration, because of the geological characteristics of the existing mines and the areas that we know, most probably there are about 300 years. Okay. With the existing reactors, the light water reactors. But these reactors only utilize 0.6% of the theoretical energy which exists in the uranium. Only 0.6%. So the generation 4 technologies are fast breeder reactors, right, which try to multiply that by factors of 30 times, 50 times. And the idea will be to start to have those reactors in operation about 2040.
30 to 50 times better than we do today. And with today's technology, 300 years. So we go out 10, 15,000 years of uranium resource.
So this is why generation 4 exists, because it's extremely attractive for the countries that have the technology
Absolutely.
to master thousands of years of energy. For base load, really the competition is between coal, natural gas, and nuclear. And nuclear has the advantage of not emitting CO2, so it's a very clear advantage, and also that economically you can expect to be very competitive because the prices of these other commodities are going to go up in the coming years. So that's very clear. That competes very well. But we have to also consider renewables, especially from a sustainability point of view. But from the economical point of view, renewables have two, let's say, challenges. One is that they are intermittent, so really cannot be used for base load, and you need to provide electricity 24 hours a day. So logically, nuclear does not compete with them because of that. And the second is that so far, these renewable energies are in the market because they are subsidized. Our analysis that is any of them cost at least, especially wind, is practically double the cost than coal, gas, or per kilowatt hour or nuclear at this moment. Solar, much more than that.
Sure.
But this doesn't mean that we should not do renewables. No, renewables are extremely important, and I think we have to look at the future in which both nuclear and renewables really serve our societies well.
I know the futures market for uranium, at least a year ago, you saw it start to go up, which
Yes.
always signals
Yes,
supply attention.
Yes, because many countries have announced investments in the nuclear sector. Some of them are already doing that. And our prospects, we have made a very recent analysis on the prospects of nuclear power. And there are 438 reactors in operation now, about that. And we expect in the low case, even if nuclear is not very attractive, to have about 600 in 2050. And since many of the existing reactors will be shut down during this period, this means that you can count on about 300, 400 new reactors in the coming years, for sure. Of course, if nuclear becomes very attractive, because prices of oil continue going up, and natural gas and all that, we think that we could go up to 1,400 reactors in 2050.
1,400
It could
reactors
be. We think this is the maximum that
by
could be done.
2050.
Yeah.
And that's in OECD countries only?
No, it's around the world.
That's global.
It's global. It's global. And we think that is feasible. But of course, it's going to depend on the evolution of many, many things, including the climate change, whether there are taxes or not to the fossil fuels, how the renewables perform, whether they are very attractive or not. It depends on the prices of oil and gas. But we think that it will be between 600 and 1,400. These are complicated technologies. They are, also at this moment still economically out of question, and a lot of research has to be carried out. But if you look at how the demand of energy, and especially electricity, is going to happen in the decades to come, I think it's very clear that we are going to need all the energies, especially the ones which don't produce CO2. So from that point of view, I think that governments do well when they develop research in many different areas, including nuclear.